and the division is necessary. Number 6 is C. Number 8 is A. Number 14, your form should have been A over 1, x plus 2 to the 1 power, B over it squared, C over it cubed, and D over it to the 4th. Number 22, in this section they said, let's start solving, not just the forms. Actually, it started in like number 17 or something, right? Number 22, the form should have been, now pause. Ready? Could you have theoretically written the factors x plus 2 here and x minus 3 there? Yeah. Could you theoretically have an A over this guy and a B over that guy? Yeah. So you're not necessarily checking, ooh, did I put A in the right spot? No, it doesn't matter. It's just an unknown. What matters is what you got as the coefficient over x minus 3. And what you got as the coefficient over x plus 2. Ah! But wait, 4/5, there's only a 4. What did they do with the 5th? Why'd they pull it in front? Because what did they both have in the denominator? So instead of writing 4 over 5 and 1 over 5, instead of even just dropping the 5 down, they said, forget it. Why don't we just pull the 1/5 out? Because it's in both of them anyway. You don't have to have it written exactly like this. But if I were you, I would, in a colored pen, write it like this. Because couldn't this be the multiple choice answer you'd have to make it match to? And I wouldn't want you guys to get thrown off on a test. You see what I mean? Okay. Anyway, so even if you didn't write it in this way, you could still be right. If you wrote 4/5 and 1/5, you're right. If you put 4 over 5 x minus 3 and 1 over 5 times x plus 2, you're right. Just make sure you can make it match. Whoo! Puppy, look at that one. Pause. What? No. What procedure did they do? Can you guys tell if they're writing it all out and multiplying and distributing it all and getting all the x cubes and all the x squareds and all the x's and all the non-x's? Did they do the trick? They didn't do the trick, but what could you have done? No. Could you have done the thumb trick, yes or no? No. Pause. Hey. You can be a little loopy when you come to a crazy example like this. I get it. There's a lot of work. I get it. You can like groan, but you should have groaned last night, right? Okay, so what are we thinking of now? How you can get it right and show off your amazing mathematical skills in section 7.4. Now wait, pause. They did it the way of check it. They multiplied everything out and got all the cubes. This would have been on my page one color. That would have been a different color. That would have been a different color. That would have been a different color. You could have set the cubic one equal to, there's no cubics, equal to 0. Oh, which they did. You could set the squared one equal to, there is a squared, 1, equal to 1. You could take the x one, you could set him equal to, there's no x, okay, 0. And the constant one, there's no constant, okay, 0. That's what they did. They were doing the grouping by the different types of terms method. But pause, did anybody do a shortcut? Can't do the thumb trick. He's not linear. He's quadratic and can't go any lower. Can't do the thumb trick. But what could we do? Plug in the zeros. What's one of the zeros you could plug in? How about -2? If you plugged in -2 to this side, you would have gotten 4. And then you would have gotten -2. Oh, you would have gotten a number with A. But here, -2, that'd be 0. And here, -2, that'd be 0. You would have gotten A by plugging in -2. There's one less variable to solve. What's another 0? +2. If you had plugged in +2, you would have gotten 4. +2, well, you actually would have gotten 0, even with the A plugged in. +2, ooh, you would have gotten a number for B. +2, you would have gotten 0. You would have gotten B with +2. But at that point, are there any more zeros for us to find? So after you use the zeros, -2 and +2, the book or my notes would say, I don't remember what the book says, convenient values. What were some convenient numbers that you could have plugged in? You're missing C and missing D after plugging in both of those zeros. You plugged in 2 and -2. What are some easy numbers to always plug in? 0 and 1? You could have plugged in 0, could have plugged in 1. You would have gotten 2 baby systems with 2 unknowns, and you could have solved it with elimination. Let me show you really quickly in notes what that would have been like. That would have been similar to 2, 2, 2, this one, I think. Yeah. Now, okay, this one looks a lot easier, right? But it's similar to this one in that you would have plugged in a 0 and gotten 1. You would have actually plugged in another 0, gotten another, but then you had to choose some other convenient values. And these other convenient values didn't get you lots of zeros, but they do get you little baby systems you can put together and solve. That's what you could have done if you don't like the multiplying it all out and making a big old system of equations. Because if you guys notice, how many equations do you end up having at the end of this? 1, 2, 3, 4. Whew. 4 equations and 3 unknowns. Oh, dear. You would have had to go setting up a system and trying to solve that. Hey, I'm missing A and B and C, and then A and B and D, and then A and B and C, and then A and B and D. Oh, man. I think I would have gone for trying to eliminate C in the C equation, trying to eliminate D in the D equations, and then you would have had 2 A's and B's you could have put together. So they're just putting it all in words. But was there another way? The answer was yes. You could have used the zeros and 2 more convenient values. At the end of the day, do you guys see the final answer? Whatever your A's and B's, whatever your letters are, you should have gotten a negative 1/6 over x plus 2, a 1/6 over x minus 2, and a 1/3 over x squared plus 2. The x term actually ended up, C actually ended up being 0. So you could have had that guy, C was 0, and then D. Cx plus D, D was 1/3. What they ended up doing next is, if you guys notice, they popped down those guys. They popped them all down. They wrote the positive guy first, because usually in math we don't like writing the negative guy first. But then they actually went ahead and got a common denominator. They made this guy 2/6 instead of 1/3. So they made him 2/6, so that way you were able to pull the 6th out of everybody. So they got a common denominator, pulled the 6th out, and then there you go. Number 44, you guys can already check it, was a weird one because it was improper. Why was it improper? Top heavy is equal to or greater than on degrees. So the degrees were equal, so they had to do long division. When you did long division, you would have gotten 1 minus the remainder. Now, whoa, yeah, wait, hold on. Whenever we do these types of problems, we have to take the remainder and break it down. Isn't that what we did yesterday? Okay, so hold on. They cheated. Something's wrong. Maybe it's on the next page. Because you should have totally tried to factor, oh, this guy. We had to factor, right, to break it down. When we factor him, wouldn't that be x plus 3, x minus 2? No, because that would be minus. Oh, well. Okay, worst comes to worst, x equals negative b plus minus square root of ac all over 2. Are there any factors that are real? No, they're all imaginary. Square roots of negatives, we can't have that. So there are no factors? That's an irreducible quadratic. If it's irreducible, do I need to break it down anymore? Nope. I tried, but guess what? It's as broken down as it can possibly get. This guy doesn't have any lower pieces. He doesn't decompose anymore. Thanks, Austin. He doesn't decompose anymore. So ironically, you were done just with a division. That was a nice problem. Are we done? Ah, now we're done. All right, cool kids. What do we got? Questions? Kyle.
For number 36, I was just looking at the zero. When you did the zeros, I was just a little confused because it seemed like sometimes the zeros weren't matched up. Like it would be.
You mean like if I was to do the zeros? I could do them quick. I don't mind. Sorry, I was saying them and not really doing them. But you see where I'm getting the zeros from, right? Okay, so x equals negative 2, x equals positive 2, and then I have 4 unknowns, so I'm going to have to go more, but that's okay for right now. I'm plugging negative 2 into this big old string. And where did this, Kyle, can you verbalize for me? Where did this whole blech come from? Right, when you get rid of the denominator. So we would have gotten common denominators, multiplied this guy by the other 2, boom, boom, multiplied that guy by the other 2, boom, boom, multiplied that guy by the other 2, boom, boom, and you get this big old whew. So plugging in negative 2 squared is 4. Negative 2, well, I have a times negative 2 minus 2 is negative 4. Negative 2 squared is 4. 4 plus 2 is 6. But then what I see and what I like, remember, negative 2 will make this guy 0. So when I go to plug in here, that's going to be 0. When I plug in here, that's going to be 0. Just because of the nature of plugging this guy into the factor that's multiplied by other stuff. Does that make sense? And so then if I end up dividing 4 by negative 24, a equals negative 1, 6, which we've already seen is the case. Does that make sense? And so the zeros are always nice because even though when you plug in the zeros, you'll have some numbers, whoever the 0 is of, like the factor, whenever you see that factor, plugging in 2, 2 minus 2 is 0, that whole thing is 0. Even though I know a and I could have plugged him in. Still, because now I know a is negative 1, 6. Still, when I plug in 2, that whole thing is 0. When I plug in 2, oh, no, that's a number. Because 2 plus 2 is 4. 2 squared is 4. 4 times 2 is 6. 4 plus 2 is 6. But when I plug in 2, 0 makes that whole thing. That's why the zeros are so nice. And you end up with b is equal to 4 over 4, which we already saw was right. But here's where I'm stuck, because I can come back and I can plug in a. I can come back and I can plug in b, but the problem is, what do I still not know? But this is where that other convenient values comes into play. Because the nice thing is, by plugging in the zeros, which made the math easy, we haven't even touched yet 2 other very convenient values, meaning easy for my head to plug in. So I would go 0 and 1. You could go 110 and 537, but I don't want to do that math, do you? So I'm plugging in some easy ones. When I plug in 0, it's just 0. When I plug in 0, well, I sadly have negative 1, 6, my a. 0 minus 2 is negative 2. 0 plus 2 is 2. When I plug in 0, I have my b, which I know is 1, 6. 0 plus 2. 0 squared plus 2. When I plug in 0, well, c goes away. I just have d. 0 plus 2 is 2. 0 minus 2. So you're going to have some math that you need to do. Let me see if I can do this pretty quickly. That's going to be 2/3, right? Positive 2/3 and another positive 2/3, that's 4/3. D, 4d is 4/3. Oh, I have to subtract 4/3 on the other side, huh? 4/3 minus 4/3 equals negative 4d. So I'm going to divide by negative 4, which means multiply by 1 over negative 4. So d equals 1/3. At this point, Kyle, just because we've already looked at the answer, when you go to do one last plug-in, when you go to plug in now knowing that your d is positive 1/3, we've already seen, like behind the curtain, we've already seen what's going to happen. We've already seen that c equals 0, so you're going to be done. But normally, like a number 2, then we come back, plug in, plug in, plug in, plug in. Yeah. Any other questions? Evens or odds? Yeah, Austin. Yeah. Okay. The grouping like with the these ways? Oh, like when you had so many different variables? Okay. Let me, if you don't mind, I can just take a picture right here, right? Okay. This one's really unique because actually it's easier than it could have been, because it could have been 4 variables, A, B, C, D, A, B, C, D, A, B, C, D, A, B, C, D. That would have been awful because then we would have had to have 4 equations, 4 unknowns, and we would have had to go for our system. But even harder than section 7.3 ever was, because we have 4 instead of 3. This one's actually a little nicer. Sorry, over here was x squared. The trouble with x squared, since it was alone, it actually meant there was a 0x and a 0, and it meant that there was a 0x cubed. And the reason why I'm writing that is because when we go to do each of our different ones, I mean, I was color coding, you didn't have to. But when we go to take our x cubes, we need to know what it equals. And since there wasn't any, then I'd just say a plus b plus c had to combine to be 0. So that's how they got their first one. I'm going to go see if there are any other a, b, c ones. Here we go. And I'm going to steal him too. So a and b and c had to combine to be the x term, which would also be 0 again. So 2a plus 2b minus 4z is equal to 0, 2. And the reason, Austin, I'm stealing these is because out of all of them, they're the only two that have a c. So what I'm going to actually do is I'm going to go aiming for, well, that's not going to help me here. There we go. I'm going to go aiming for eliminating the c variable. Because if I can do a quick little like elimination, there we go. I'll end up with 6a plus 6b equals 0. You'll see why this is helpful in a second. Now I'm going to go ahead and go steal someone else. Let's see, what else do I have? I have x squared terms. And I actually have one of those. So I'm going to say my negative 2a plus 2b plus d is equal to 1x squared. There's another set of a, b, d's. Go steal him, and that's going to need to be my constant, which is 0. So that'd be negative 4a plus 4b minus 4d equals 0. I'm going to do an elimination with this too, but I'm going to go eliminating the d variable, and maybe now you'll start to see what I'm doing. If I can eliminate the d's by multiplying by, yeah, I'm just going to do a 4, sorry, just to save on space. Negative 8 minus 4, so dangerous to be doing, but you guys are double checking my math, right? Negative 8 minus 4 is negative 12a. 8 plus 4 would be 12b. 4d minus 4d is 0. And then 4 plus 0 is 4. All of a sudden, my life just got better. So what I would do at this point is I would do your little baby system, probably multiplying, eliminating a. That's probably the easiest. Well, I'm multiplying by negative 2, eliminating b. But do a quick elimination. Plug back in to get b. And one of these, and b back here, and one of those to get c. Is that cool? Yeah. But so glad, I mean, for your sake and for mine, so glad that it didn't have 4 variables, because at that point we would have tried to get to row echelon form. Ugh. But super soon, we're getting to matrices. And the cool thing about matrices is once I can show you guys the logic behind the programming, so that you've been able to think through the math and then think through how the programming works, then we can start to use the calculator to be like, oh man, that'd be hard to do by hand, but my calculator has it all programmed in and will do it for me. That's coming, just it didn't need to happen in this section. That's, I think, in chapter 8 with matrices. Okay, with that, we have questions on odds, you guys. Go. Quick, turn around. Give 3 people high fives. Because I have some people falling asleep because it's nice and warm in here, which I appreciate until you start. Thank you, Adam. As you guys are getting out your notes, I do want to pass out the test, but I told you I would get you going on one last Mama Bahama question. Because if you've gotten through homework, and if you've asked me the questions, you should be able to bust out this guy. You're missing an A, you're missing a B, you're missing a C, you're missing a D. You, in your groups, choose a way. Are you going to do the multiplication and group up the x cubes, x squareds, x's, and constants? Or are you going to do convenient values with no zeros being present? All right, let's just go for 4 random numbers and plug in. What does your group like more? Numbers or equations? Numbers or equations? Choices. Sorry, that's a really awkward D. Let me pass out tests. We've saved this until the very end. In your groups, in your groups, in your groups. Choose a way. You have to explain the way to some extent. The grades have been on RedWeb for a while. Some of you guys might have seen them. Some of you guys might not. But we do have another test coming. There you are. Tony. All right. With I went to go find the x cubes, the x's, and the constants. I went to go set up systems. Okay. How many of you guys went? I just wanted to plug in numbers. 2/3 of the class. What'd you do? Nothing? Huh. Now here's a better question. I saw hands in almost every group. And how are you supposed to be doing this problem? In groups. And if your groups are not participating, if your groups are not working together with you, what do? Be annoying. Clap in their face. Be like, hey, we're supposed to be doing this together. Why am I saying that? One day, very soon, you are going to be in college. How many group projects? There can be quite a few. And depending on the project, guess what? In college, you don't have time to do the whole project by yourself, for your group. And there are these little papers that are like, hey, how much work did everybody do? So what do you need to do if you are on a team, even in a business one day, and your success depends on doing their part? You be annoying and you say, I need you to do the work that you're supposed to do. Let them know that you value them to some degree, but then at some point you have to be like, hey, pay attention. Hey, stop talking to your friends. Hey. Now, if you don't know what to do, what do? If your success depends on them, help them out. So let me ask one more time. There were only 2 approaches to this problem because thumb trick doesn't work. There was either the grouping way, find the x cubes, the x squareds, the x's, and start making equations, or the plugging in numbers way. There was only 2 ways. How many of you guys went the grouping route? How many of you guys went plugging in numbers route? Okay. So, long story short, even though I still have like 1/3 of the class that supposedly still did not collaborate with their group at all. Next time you're going to be annoying and in their face and say, hey, you're a part of the team, you're a part of the group, I'm not going to leave you behind. Hey, that's a Christian duty too, not to leave anyone behind. You know how Cain said, I'm not my brother's keeper? Guess what we're supposed to be? Our brother's keeper. That was sin on his part to be like, I don't care, where's my brother? I don't know. And he did know, he killed him. But anyway, coming back. Whole other issue. We're supposed to be looking out for each other. There's verses in Jude, there are verses in James that you're supposed to be looking out for each other. Here we go. The grouping way. I have 8x cubed plus 13x over here. Did you guys get ax cubed plus bx squared plus 2ax plus cx plus d? Addition's commutative. Addition's commutative. Oh, there's a 2b. Good, good, good. Right here, right? To be or not to be? Yeah, that was my joke from yesterday, huh? And the Hamlet soliloquy. What do I see? X cubes, didn't you? Can't we just say 8 equals a? 8 had to come from a. There's no other x cubes. Sweet. Now what? Are there any x squareds? Sweet. So doesn't 0 equal b? Because there would have been a 0x squared over here. Now we have x and cx, right? Have to combine to be 13. So 13 had to come C. And who's our last guy? Well, we have 2b and we have d, and we have no constant over here, right? So then 2b plus d had to come from 0. Or maybe, to make it nicer, because I was writing the left side for all the rest on the left, 0 had to come from 2b plus d. So what did we know? Hey, we got one. Hey, we got one. Hey, that's okay.
We know that.
Can't we take a and plug it? So 2 times 8. 13 minus 16 isn't C. I think the group way was the fastest way on this one. Because the other way you would have had to plug in 4 numbers and do a lot of cubing and squaring and possible. Times faster on this one. So then come in here. Don't we have B? B is 0. What do we do with all these values once we have them? plug back into the original. So the form from up above of the partial fractions was, who is A? 8. 8x plus, who's B? 0. Okay, just 8x over, right? Plus, who's C? Negative 3, who's D? 0. So negative 3x over x squared plus 2. Dun, 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 dun. Who got there before me? Ooh, okay. Kyle. You could do positive or minus, yeah. Or minus a positive. Gavin, what were you saying? Still a little... Because you guys were doing numbers, yeah, that would have taken a lot longer, huh? But does this process make sense? Yeah, no, that's okay. That's okay. Any questions, though? Yeah, Robbie. Remember, in partial fractions, when you make the forms, anytime the denominator has a squared in the factor, in the parentheses, it can't go down anymore. Now, I could try to go more. I could say x squared plus 2, come on, it has to have some zeros. It has to have some factors. But the reason why I know it doesn't is because they're imaginary. Since you can't go down any farther, anytime you have an x squared, the partial fraction is going to be a line, which means it needs like mx plus b, but we use like the capital letters instead. Yeah. But if it was just x plus 2, it would just be a. Or x plus 2 squared, it would just be b. Or I guess c. Or a. Anyway. But since that's that quadratic that I can't break down any farther, I need that ax plus b, cx plus d. Yeah, just keep using letters. All right, cool kids. What's next? Systems. Oh, that makes sense. Isn't this whole chapter systems? Partial fractions. Need us to solve systems. Oh, okay. 7-1, substitution with systems. 7-2, elimination with systems. 7-3, row echelon form with big systems, like 3 variables, 3 equation systems. 7-4, partial fractions need systems to solve. But what's different in 7-5? Systems, got it, of? Ooh. Shady. Why is Kyle saying shady? He might have just been saying shady because something he felt was shady, but it's perfect, yeah. With inequalities, shading above, below, dotted lines, solid lines. But if it's systems, we're not just having one, we're having multiple. We're having multiple. Now, the nice thing is, didn't you guys remember that we're not graphing 3-dimensionally in pre-cal this year? Not really. Although some of you, maybe for future STEM stuff, it might be good to look at chapter 11 that does have 3-dimensional vectors. Anyway, if we're not doing 3-dimensional graphing, what does that mean we won't be seeing in 7-5? X, Y, Z. We'll only be seeing... Okay, that's nice. But do they all have to be lines? Nope, we could have parabolas, we could have circles, we could have all sorts of different equations. But good news is, no 3 dimensions, no z's. No 3 dimensions, no z's. Let me go ahead and zoom in. It's kind of small, huh? What are we doing? Section 7.5, systems of inequality. Let me give you a second. You guys just go ahead and write. Long story short, we're going to have systems, but the systems won't just have equals. Greater than, less than, greater than or equal to, less than or equal to. Question, if the inequalities are or equal to, greater than or equal to, less than or equal to, I already heard the answer, but did the rest of you guys hear it? What kind of lines are we going to be forming? What kind of boundaries? Solid. What if it's just greater than or just less than? Dotted? There you go. So right now, it might be a good idea if you guys have something that you can use for multiple colors. If we have systems of inequalities, we're going to be putting multiple graphs together with multiple shadings, maybe colored pencils, maybe highlighters, maybe even the pen that you use to grade versus the pencil. At least we can kind of try. I would try to get out as many colors as possible, although some of you have whole bags of colors, so maybe not every color, but get colors available. Maybe a black, maybe a blue, maybe a red with your pencil, that would work. Get a few colors ready for me because we are today looking for overlap. We are looking for overlap, but not just overlap of 1 or 2 or 3, but overlap of all, whatever it is they give to us. Not just overlap of 1 or 2 or 3, but overlap of them all, everything they give to us. All right. You guys see an example. Have you graphed them yet? Ready, set, and let me scroll down just a little bit. Go. It's not a line, but can you still do it? Go for it. It's not a line, but can you still do it? Hello? You can take your stuff, kiddo. That's what she said. I don't know. All right. Guys, was it as easy as knowing this was a parabola, shifted 1 down, and then being like boom and boom, and making it solid because boom, and then going ahead and saying, oh, why? 2 ways of thinking about it. One way, greater than means up. But not every graph is quite as straightforward as greater than means up. Some graphs, where's the up? Some graphs, just warning, some graphs, like circle, where's the up? But is it? Anyway, coming back. A safe way to make sure, right? The shading should either be here or here, either inside or outside, right? So if worst comes to worst, you can always pick a test point like 0, 0 is a good test point. If I plug in 0, is 0 greater than or equal to 0 minus 0 squared? Minus 1? Yes. If it's true, guess what? Wherever it gets shaded. Quick double check. Quick double check that your shading is right. But that wasn't bad, right? So what happens when you have a system? Multiple conditions are involved. That makes sense. Multiple system, multiple. Okay. Multiple conditions are involved. A solution is going to be a point that satisfies each and every inequality. Each and every inequality. So what are our steps? Sketch each and every inequality. Shade whatever regions you need to be shading, because that's part of sketching, right? Part of sketching is the shading. Figure out the overlap. Figure out what region is in common. And if worse comes to worse, you can always just test sample points. But do you guys see an extra little note down below, above and beyond what we've talked about today? Vertices. Vertices. Does that sound like corners? Guess what vertices are? Let me see if I have a nice little way of saying them. No, I don't. That's okay. Vertices. Vertices are, in some ways, shapes, or forms, the corners of the regions. And guys, if you have multiple graphs coming together, what's going to form the corners? The intersection. Corners of the regions are found from the intersections between each of the conditions. Each of the conditions, yeah, because one corner might be formed by like two of the conditions, but another corner is formed by another two conditions. But the vertices are going to be very helpful when thinking about solutions, since the vertices are just the corners. The corners are just the intersections. So if you're given something, and the directions are sketch the graph and label the vertices. Well, first of all, I don't like that first equation, right? Do you? But what would be a lot better way of thinking about this equation? How about y is greater than negative x, no, positive x minus 2. Wait, what did I do? How did I? Can add the y and subtract the 2, and the y ends up on the greater than side. Or you could subtract the x and divide by a negative, which flips the inequality and flips the two signs. But when you go to graph this one, and if you graph the negative 2 going up 1 over 1, up 1 over 1, with a dotted line for the first condition, and then if you graph x greater than negative 2 for the second condition, shading it, y less than or equal to 3. Do you guys see corners? I do. If you were to do all the shading together, guess what you would find?
It's a triangle.
But how would you find the vertices? Two at a time. Say, hey, what do you two share? What do you two share? What do you two share? And I think pretty quickly you'll get those. Apply that a little bit deeper in homework. It probably won't be due until Monday, but start tonight, start tonight. Bye, guys.